we are going to see another important topic and quite interesting, that is electric potential. Okay. First we will define the term, and we'll understand what this uh, means. Okay. Electric potential, it is basically defined as the work done in bringing a unit positive charge from a reference point to a required point. Reference point, here we take it as infinity. Okay. A unit positive charge from infinity to the given point or required point. Okay. In electric field, against electric force. Here we are taking our reference point as infinity and our required point as the given point where we want to know the electric potential. Okay. So this is it. This is electric potential, defined as the work done in bringing a unit positive charge from an infinity to the given point in electric field against electric force. Okay. So it is basically defined as, suppose we are bringing a unit positive charge from initial position I to final position. Okay. Against electric field. Okay. So Vf minus Vi, final potential minus initial potential, will be W external, work done by the external agent, divided by Q. Q will be the magnitude of charge. Okay. And this W external can be written as minus Q E dot dr over Q. Okay. From initial position to final position. Okay. This Q gets cancelled out. Okay. And if we are considering, write it like this way, Vf minus Vi is equals to minus E dot dr. Okay, I'll tell you how this formula, that is W external is equals to minus Q E dot dr. How this formula came, I'll tell you just after this. Okay. Uh, so Vf minus Vi is equals to E dot dr from initial to final. Okay. Now, if we are considering our reference point, okay, as infinity, okay, so Vi will be what? 0 if reference point is infinity. Okay. So what happens? Vf becomes V. Okay. Is equals to minus E dot dr from I to L. This is what? This is our electric potential, right? Which we require. E dot dr from initial to final, and here our initial is infinity, from infinity to final position where we require. Okay. So now we have to know how this formula came, that W external is equals to minus Q E dot dr from initial to final. Okay. I'll tell you this. Suppose there are electric field lines. Okay. Like this. Okay. uh, we are considering a positive charge. Okay. Plus Q. Okay. Here, right? What happens if electric field lines are like this? Then this will be the direction of electric force F electric. Okay. And this will be what? It will be Q into electric field intensity or electric field strength. Okay. So if we want to move this charge in this direction, okay, then external agent must do work in this direction. Okay. This is F external. if we want to hold this charge in this position, okay, since a force has been applied by electric field in this direction, in the forward direction, okay, so if we want to hold this charge in this position, okay, in this position, then we have to apply a equal and opposite force, okay, so this will be the direction of electric, oh sorry, external force, okay, this will be what, it will be minus q into e, right? Now we want to calculate the external work, okay, suppose we have moved this charge a distance dl, okay, a distance dl, okay, uh, like this, okay, suppose, okay, so what will be the work done, dw, it will be external agent, work done by external agent, it will be f external into dl, obviously, okay, uh, we are considering a very small elemental area, oh sorry, elemental length, so that there is not there is no variation, okay, in electric field, okay, like this, okay, so dw external will be f external into dl, okay, and we know that f external is what, it is minus q into e into dl. Now if we want to move a positive charge from this point initial I to final point f here, then what we have to do, we just need to integrate this, okay, from I to f, okay, from I to f, okay, so here from here what we get w external is equals to minus q vector e dot dl from initial position to final position, okay, so this is the formula that we have used in determining electric potential, okay, work done by external agent in the previous slide. Here we have used this formula, okay, so this is a basic definition and how we have derived the electric potential. Now uh, talking about the unit will be what, it will be volt, obviously, okay, uh, then other units as well you can derive it, okay, dimensional formula of this will be what, uh, you know the dimensional formula of electric field, okay, I have told you in the previous video, okay, in the previous lecture, so dimensional formula will be just multiply it by give, okay, so it will be m l square t power minus 3 a power minus, this will be the dimensional formula of electric potential, okay, so these were the basic things